Imagine discovering that Earth's future may already exist, not in a computer simulation, not in a distant galaxy, but on a planet right next door. A world where a single day lasts longer than an entire year, where the surface is hot enough to melt lead, where the atmospheric pressure is so intense that it could crush you instantly. A planet that was once thought to be covered in oceans and perhaps even capable of supporting life. Yet today, it is the hottest planet in our solar system, even hotter than Mercury, despite Mercury being much closer to the Sun. This is Venus, Earth's mysterious twin. And according to scientists, understanding what happened to Venus could help us understand the future of our own planet. How did two worlds that began so similarly end up so different? What transformed Venus into a planetary nightmare? And why are space agencies around the world racing back to this hellish world? This is why Venus is called the planet that could predict everything. For thousands of years, Venus fascinated humanity. As the brightest object in the night sky after the moon, ancient civilizations associated it with gods and goddesses of beauty and love. Its thick blanket of clouds concealed its surface completely, fueling endless speculation about what lay beneath. In the early 20th century, some scientists imagined Venus as a tropical paradise filled with vast oceans, dense jungles, and perhaps even alien life. And honestly, it wasn't an unreasonable idea. Venus and Earth are remarkably similar. Venus is about 95% the size of Earth. It has nearly the same mass and density. Both planets formed around 4.5 billion years ago from the same cloud of gas and dust. In many ways, Venus is Earth's closest planetary sibling. But when humanity finally reached Venus, everything changed. Beginning in the 1960s, the Soviet Union launched a series of spacecraft known as the Venera missions. These missions became the first to survive the descent through Venus's atmosphere and transmit data from its surface. What they discovered shocked the world. Venus wasn't a paradise, it was hell. The surface temperature averaged around 465 degrees Celsius, hot enough to melt lead. The atmospheric pressure was more than 90 times greater than Earth's. Standing on Venus would feel like being nearly 1 kilometer beneath Earth's oceans. The atmosphere was composed of approximately 96% carbon dioxide, covered by thick clouds of sulfuric acid. The Venera landers survived only minutes before being destroyed by the extreme conditions. Yet those few minutes transformed our understanding of Venus forever. But perhaps the most surprising fact about Venus is this: it is the hottest planet in the solar system. Not Mercury, Venus. At first, that doesn't make sense. Mercury is much closer to the Sun. So why isn't Mercury hotter? The answer lies in Venus's atmosphere. Mercury has almost no atmosphere to trap heat. During the day, its surface becomes extremely hot. But at night, temperatures plummet dramatically. Venus, however, possesses an incredibly thick atmosphere dominated by carbon dioxide. This dense blanket traps heat through an extreme greenhouse effect. Solar energy enters the atmosphere, but the heat struggles to escape back into space. As a result, Venus maintains scorching temperatures across its entire surface, day and night. It is the ultimate example of a runaway greenhouse effect. And that's exactly why scientists study it so intensely. Venus also has some of the strangest characteristics of any planet in the solar system. For example, a day on Venus is longer than its year. Venus rotates incredibly slowly. One complete rotation takes about 243 Earth days. Meanwhile, Venus completes an orbit around the Sun in just 225 Earth days. This means that Venus takes longer to spin once on its axis than it does to travel around the Sun. Even stranger, Venus rotates backward compared to most planets. On Venus, the sun rises in the west and sets in the east. Why Venus rotates this way remains one of planetary science's enduring mysteries. But perhaps the biggest mystery is what Venus used to be. Scientists believe that billions of years ago, Venus may have looked very different. Computer models suggest that early Venus could have possessed shallow oceans of liquid water. Cloud systems may have reflected sunlight and helped regulate temperatures. For billions of years, Venus might have maintained conditions suitable for habitability. If true, Venus wasn't always a hostile wasteland. It may once have resembled Earth, but Venus had one critical difference. It orbited closer to the Sun, receiving nearly twice as much solar energy as Earth. Over immense periods of time, temperatures gradually increased. As Venus warmed, more water evaporated into the atmosphere. Water vapor is itself a powerful greenhouse gas. The more water vapor entered the atmosphere, the more heat became trapped. The additional heat caused even more evaporation, which trapped even more heat, creating a devastating feedback loop. Scientists call this process a runaway greenhouse effect. Unlike normal climate systems that stabilize over time, a runaway greenhouse effect accelerates uncontrollably. Eventually, Venus crossed a tipping point. Its oceans evaporated completely. Without liquid water, there was no mechanism to remove carbon dioxide from the atmosphere through geological processes. Carbon dioxide accumulated. Temperatures soared. The planet transformed into the inferno we observe today. Ultraviolet radiation from the sun eventually broke apart water molecules in the upper atmosphere. Hydrogen escaped into space, leaving Venus permanently dry. A world that may once have had oceans became a barren wasteland. This is why Venus matters, not because scientists believe Earth will suddenly become Venus, but because Venus provides a natural laboratory for understanding planetary climate evolution. It teaches us about atmospheric feedback loops, climate stability, habitability, and the delicate balance required for life to exist. The comparison between Earth and Venus reveals an astonishing truth. Small differences can lead to dramatically different outcomes. Two planets, similar sizes, similar origins. Yet one became a thriving world filled with life. The other became a furnace hot enough to melt metal. And scientists are still trying to understand why. Fortunately, decades of exploration have already revealed remarkable clues. NASA's Magellan spacecraft, which orbited Venus from 1990 to 1994, revolutionized our understanding of the planet. Using radar to penetrate Venus's thick clouds, Magellan mapped approximately 98% of the surface in unprecedented detail. It revealed a landscape dominated by vast volcanic plains, enormous shield volcanoes, mountain ranges, and massive geological structures unlike anything seen on Earth. The mission showed that Venus had undergone extensive volcanic resurfacing in its past, suggesting that the planet remained geologically active far longer than previously thought. More recently, scientists analyzing data from the European Space Agency's Venus Express mission found evidence suggesting that Venus may still be volcanically active today. Venus Express, which operated from 2006 to 2014, studied the planet's atmosphere in detail. It detected unusual variations in sulfur dioxide concentrations and identified regions emitting unusually high thermal radiation. These observations hinted that active volcanism could still be reshaping Venus's surface. If confirmed, it would mean Venus is not a geologically dead world, but a dynamic planet that continues to evolve. Even missions not specifically designed to study Venus have contributed valuable discoveries. NASA's Parker Solar Probe, launched to investigate the Sun, has performed multiple gravity-assist flybys of Venus. During these encounters, Parker's Wide-Field Imager for Solar Probe unexpectedly captured thermal emissions from Venus's surface through its dense cloud cover. The observations revealed differences between highland regions and surrounding lowlands, providing new insights into the planet's geology and surface composition. The Soviet Venera missions also achieved another extraordinary milestone. Several landers transmitted the first images ever taken from the surface of Venus. These photographs revealed a barren landscape scattered with fractured rocks beneath an orange-tinted sky. Combined with direct measurements of temperature, pressure, and atmospheric composition, they provided humanity's first glimpse of conditions on Earth's mysterious twin. Each mission has added another piece to the puzzle. Together, they have transformed Venus from a hidden world of speculation into one of the most scientifically important planets in our solar system. The more we study Venus, the more intriguing it becomes. Because Venus isn't simply a cautionary tale. It is a key to understanding planetary evolution throughout the universe. Thousands of exoplanets have been discovered orbiting distant stars. Many exist within so-called habitable zones, regions where liquid water could potentially exist. But Venus reminds us that being in the right location isn't enough. A planet can begin with enormous potential and still lose everything. Understanding Venus helps scientists determine which distant worlds might truly support life and which may already be doomed. Perhaps the most unsettling aspect of Venus isn't how different it is from Earth, it's how similar it once may have been. Venus forces us to confront an uncomfortable reality. Planetary futures are not guaranteed. Habitability is fragile. Even worlds that begin alike can end in dramatically different ways. And maybe that's why Venus captivates scientists so deeply. It isn't merely another planet in our solar system. It is a warning, a scientific mystery, a natural experiment billions of years in the making, and perhaps a glimpse into understanding our own world. Because sometimes, the best way to understand Earth's future is to study a planet that may have already lived through a very different version of it. Venus, the planet that could predict Earth's future.